Hey YouTube, in this video we're going to discuss what we refer to as Descartes' rule of signs, okay? And essentially, if we want to know what Descartes' rule of signs does for us in the beginning, is it kind of narrows down the list of possible zeros that could go into this function, because looking at this function on the right here, f of x equals this third degree thing. Let's say I wanted to go find its zeros. Well, I noticed that setting this equal to 0 and solving by factoring is kind of out of the question because this is not factorable. So here we are trying to divide and divide and divide and divide until we find something that goes in evenly. What this is going to do for us is narrow down the list of things that could possibly go into it. What if I said that, hey, possibly no negative numbers could go into this whatsoever? Then I don't need to guess those numbers any longer. So let's go ahead and read through what Descartes' rule of signs says and then use that to describe the possible real zeros of this function here. So it says f of x equals some a sub n x to the n, or nth degree polynomial, all the way down to its constant term here. It says let f of x be a polynomial with real coefficients such that your leading coefficient is not 0 and your constant term is not 0. Then it says the number of positive real zeros, or possible positive real zeros of f, is either equal to the number of variations in sign in your original function or less than that by an even integer. Okay, so let's take a moment to let this sink in. What we're really saying is we want to find out how many possible positive roots could this potentially have in the first place. And what Descartes said was, if you look at the number of variations in sign of your function f of x, it's going to be equal to that number or less than that number by an even integer. So what we mean by variations in sign is this. If you go look at your f of x up here, we notice that our first term starts out as positive. A variation in sign would be, as we go left to right, if we see our term switch from either being positive to being negative or from negative to positive, we'll count that as a variation. So in terms of possible positive, we would say it's equal to the number of variations in sign. So we start off as a positive term here. It goes from being positive to being negative. So that would be counted as one variation right there. Then it goes from negative 5x squared to positive 6x, so negative to positive. There's another variation. And then from positive to negative, there's another variation. So in other words, we have 3 possible positive real zeros. Or it says less than that number by an even integer. So we say, going down by 2's now, we say if not 3 positive, then it could have potentially 1, 3 or 1. So now let's talk about how we can discover how many possible negative real zeros that this can have. So the second part of this test is it says the number of negative real zeros of f is either equal to the number of variations in sign of f of negative x, or, this is supposed to be an or, less than that number by an even integer. So that less than that number by an even integer thing is the same thing we kind of looked at here, but what this means is we have to go and find f of negative x. So when we say, well, how would f of negative x compare to this? Let's go ahead and actually plug this in. This doesn't take that long. We'd say we'll put in blanks for all of our input fields. We'd say we would get this here, minus 4, where we're putting in a negative x here, and a negative x here, and a negative x here. But what I want to point out is anytime you have an odd exponent, right here and right here, it's going to basically switch the sign that was already on that number. So this 3x to the third, because it has an odd exponent, is going to become negative 3x to the third. And this has an even exponent here, this x squared, so this is going to stay as negative 5 times a positive x squared, which is negative 5x squared. Its sign doesn't change. Now, because we have negative x to the first, that's negative x times this positive 6. It makes it a negative 6x. And this right here technically has an exponent of 0 on its x, so its sign does not change. So basically, when I tell people to go check for the possible negative, a lot of the time what I see people do is this. They go up here, and anything with an odd exponent, they say, you know what, let's switch its sign. This will be negative now. This has an even exponent. Don't switch it. This has an odd exponent. Let's switch its sign. Let's make it negative. This has an even exponent. Don't switch it. And now what we're going through and we're saying, how many variations in sign exist? So I notice that it starts off with a negative here, and it goes from being negative to being negative. So that is not a variation. From negative to negative, that's not a variation. And from negative to negative, that's also not a variation. So there are no possible negative numbers that will proceed into this evenly. Okay? So it has no possible negative roots. So essentially, Descartes' rule of signs, what it's going to allow us to do is to take that list of rational roots that we usually create as the set of possible things that go in evenly and narrow it down and say, look, at least none of them can be negative, so let's not check any negative ones out. Let's just stick with checking the positive ones here.